Uh, the first example is the web search engine. So anyone have any idea about how search engine algorithm is working? This is the way that, as your friend is mentioned, uh, this is the place that there is a different search engines because there are different algorithms. For example, Google using a different algorithm for searching by indexing the web page based on the popularity of previous background of how it's chosen by people as a user, and also by the quality of the content of the web page. So these complex algorithms make Google different when we are comparing with other search engines. So there are some ranking algorithms, and the base technique for differentiating the search engines are I can say it's the main part is the ranking algorithms from my perspective in this course. But of course, if we go beyond, there are many other factors, but I just focus the things that is based on this course. I just want to show you that algorithms are important like these, and even can make your search engine in a best position comparing to other competitors. Another place that algorithms can be used in the internet is in the internet, as you may know, when we are sending data from, for example, 1 to 6 as a source and destination, as shown in the right-hand side image. There are many routes. For example, you are sending, for example, 1 GB of data from source to destination. You cannot send just once. You just send a portion of the data from one route, another portion from another route, and these data should be accumulated and gathered on the destination, and without any problem in the data. So we assume that the data from the source to destination are the same. But sometimes there are some loss of data, but there are some algorithms to compensate that losses. This is another place that algorithms are used. So another slides is about distributed file sharing system. There are some systems that, for example, you have several hard disks, tapes, and servers, and at the network you have a number of clients. So you have to manage that. For example, if one client come and write something on the disk, how it can be updated for other clients, for example. There is a file sharing system. A shared file may be simultaneously accessed by multiple users, as I mentioned. And in such a situations, for example, the system should be optimized when it's updating the sharing, when it's a new share. So this is another application of the algorithms, and most of these algorithms can be written by the new materials that I will teach to you. Another big project is a genome project. So the Human Genome Project has some goals, and because in the human DNA there is 10,000 genes, and each has a lot of the pairs of chemical base sequences. So it's very hard to detect these things even with the current technology advancement. And there are a very complicated procedure for storing this information in databases, and the data analysis for this type of project, because DNAs has a lot of information, and they are composed with many different proteins. And for all of these things that I mentioned, we will require sophisticated algorithms to solve these problems. And at this moment, there are some computer scientists around the world working on this project. Another application for motivating you is printed circuit boards. Okay, I have a question here. So for printed circuit boards, there are some parts that we want to put on the printed circuit boards, for example, chips, microcontrollers. So there are some places, there are some routes inside the PCB, and it should be designed. And some of the routes should pass from some of the holes that we call via, and some of them shouldn't. So all these things cannot be done by hand because it's very cumbersome and time consuming. So you need some algorithms to design to how they can find the best routes between these holes that we call it via. So this is another application that can be done with what you will learn. Another place that algorithms can be used is compilers. Compilers, as you may know, just the input is the high-level language. For example, you are programming in C, but the computer can understand only low-level language, for example, assembly. So the compiler here is a set of algorithms to understand the errors and solve and also translate your high-level language to low-level language. This is another applications that you may see to use algorithms for this application. So another application is video games. I'm sure that all of you have some experience about these video games, how video games is used, and time by time they are developing and they get more sophisticated. How algorithms are used here is that, for example, as the technology is improving, the plan of your video game is based on your motions and your way of solving the problems. So they can learn from you and they will try to defeat you. So it makes the games more interesting for people, because previously the game was just very rigid. Anyone who plays, every character is moving in a very similar way. But now the games learn from you, and according to what you are doing, they will do something that makes it interesting for you. So this is another way that algorithms are used here in video games. So another place that it's very important is virtual reality. So anyone who have any idea about how algorithms can solve the virtual reality problems, like augmented realities or different kind of virtual realities? For example, you are in the storerooms and you have a very big storeroom. So you cannot, for example, determine what is the something, where is this something is, for example, you are looking for something, but you don't know where is it. Or you have a very large list of the items that you want to pick, but you don't know where you should start. It's very simple. It's based on image reading. So image, every mobile phone now has an image. You can take an image, I mean. There is a camera there. So you just put the mobile on the road, and there are some markers in the algorithm. So you write the algorithm, for example, they know that the one place, for example, one marker is on the corner right, and var marker is the corner left. And according to these corners and orientation, the algorithm automatically understand that where you are, and also it has a database. It's know that where is the packs, where is the items, and then it just show you that, for example, okay, you have to pick the this item, for example, item 15 from the yellow part, and it just mark puts the augmented reality there. And also it can gives you, for example, how many distance, how much distance is required you to pass, and what time, for example, can expect what time you need. And these things also make your life easier. This is very interesting problem, but it's all based on the algorithms and very simple database systems if you want to do something initial. But of course, if you go for advanced systems, so it will take you much more. So another problem. So this is another real problem. So, we have, I think most of you heard about travel salesman problem, but I'm not sure if you don't hear about that. If you didn't, no problem. So it's not related to this exactly, but it's very similar. So this is one example that how what you are learning can be useful in the practice. Uh, for example, we have some printed circuit boards, as I mentioned to you in previous slides. So the printed circuit boards has some places that needs to be, you need to put the chips there, exactly the same places, and fasten the chips on the substrate. So for this reason, you need to use specific robots. These robots are soldering robots. They actually fasten the chips to the place by visiting. For example, you can imagine that we have 6 different components, and we want to fasten by soldering to the these printed circuit boards. So for this reason, we have, and we want to use robots again. For example, we have 100 PCBs, and we want to do it as soon as possible by soldering it, instead of using a human to solder it, which is more time consuming, and also maybe it's not good in terms of the preciseness and the quality. So for this reason, we have to find a way, for example, for this robot arm, which is moving from one place to the place, from another place. So how we can design a tool for these robots to do these things in an optimal way, to reduce the time comparing to, for example, if we just do random things on different ways, how we can do that. So this is something we called it robot tool optimization problem. Here, I just define the problem. So the problem is that we have a set of endpoints, which we call a set S of endpoints in the plane. And the output is what is the shortest cycle tool that visits each point from the set that you have. I'm not sure if you get it, but I would appreciate if you have any comments, just let me know now. Before going to the next slide, if you have any idea how we can solve this, please let me know. I will go to the next slide. So one solution can be, for example, I think if I show you this, it's more easier to you to understand it. For example, we are in the point 0. So one way could be, for example, start from 0 to 1. then go to the another neighbor of 0, which was previously which is -1. Then from -1 to 3, from 3 to -5, from -5 to 11, from 11 to -21. So this is just based on the idea that you are in one point and you are just choose one of the neighbor of that point that it's not visited previously, and go to another neighbor, to the closest neighbor actually. So what do you think about these algorithms? Is it optimal or not? This is not correct. The algorithm is not correct in terms of time, because you can see, for example, here we are, instead of going from 0 to 1, 1 to -1, should be more better optimal algorithm to pass from these points, because this will takes up a lot of time. These algorithms give us a solution, but it's very time consuming comparing to another algorithm that I'm going to show you. So this is the second algorithm on the downside. So the idea is that you start from the, for example, 0 is the place that you will start. You started in the first algorithm. But here, we start from the far, far away place, for example, on the left-hand side. So we start from there and go to the all neighbors, pass from all neighbors, and on the 11, when we reach 11, we just close the 2 and come back to -21. So this will take less time for you. So in algorithms, that's why that we are going to use. I can see one comment that it's order n. Order of n, yeah, could be order of. This is the things that why we are using algorithms, why we are learning algorithms, because only solving a problem is not enough. Should be as optimal as possible, because we are solving one problem that have many aspects, and the algorithm should many algorithms should run simultaneously to solve the problem. So in each part, we have to do our best to reduce the computation and the time that it's needed to solve the problem. So this was just some ideas about the what is the algorithms and what is the applications. Because I was previously in the industry for some projects, I found that there are many connections between what we are learning in theory and what we are learning in practice, what we are going to do in practice. That is why that in this course, my try would be giving you some ideas about the practical works, as well as there are some good videos recorded with Professor Malik Moher in the computer science department, which is mostly about the theoretical aspects. And my goal is that giving you some tastes about how these algorithms can be applied in practice. Okay, for coursework and grading, this is some general rules. I would appreciate all to participate in the Zoom scheduled lectures. Students are strongly recommended to watch the videos before attending to the class, because my goal is that talk about the practical projects based on the what is taught in videos. Okay, I can see one comment from one of our friends that do we get any marks for attendance? No, no, there is no mark. This is for you because you will. I will try and I will do my best to give you some good ideas, and I will try to uh, help you to find what is the best directions when you are using the algorithms. So if you don't attend to the class, it will cost you to learn more and different. Cost you to devote more times to learn these things. So for the midterm exam, it would be online through UR courses. And the final exam is a closed book and cumulative, and you will use one platform that is used here in the University of Regina uh, for doing your final exam. The time of lectures here is Monday. Mondays is from 1 p.m. to 15 p.m. Is via Zoom. And office hours, I'm available from on Monday and Wednesday from 2:30 until 4 p.m. Via Zoom. And if you have any questions, you can um, come to open the link, open the Zoom link on the UR course, and just connect to the Zoom, and I can do my best to solve the problem and answer your questions if there is any. The textbook here is the Data Structure and Algorithms Analysis in C++ by Mark Allen Rees. It's available on the internet, and you can easily access. You all have access to this book. It's very well written. So method of evaluation here, there is a 4 assignment. So each assignment compose 5% of your final mark. So the midterm exam is the 30% of your final mark, and the final exam is 50% of your final mark. So I hope you all do your best, uh, learn the principle, and solve many questions. There are many uh, questions and related materials and books on the internet that you can use them. Buy this book also if you have you are interested. So you have a very good resources also in your courses. You have access to the video course, and you don't need really to be time specific. You can easily come and view the online videos anytime in any place. So this is very good. So another question I can see, do we need to use Hercules to do our assignments or exams? Okay, there are some topics here that we want to review. So the first one is review of algorithm analysis and trees. We will talk about the algorithms, how we can analyze the algorithms, for example, uh, in terms of time, in terms of the speed, in terms of the, for example, sometimes they are not good because they will take, even they kill the program, sometimes it's good. So how we can understand it, we will talk about big O, overview of other general things, binary and search trees, and other types of trees. And then we will go for priority queues like binary heaps and min-max heaps. Next, we will talk about the sorting, So sorting is very important in practical applications. So how we can sort it and what algorithms are there and how would be the complexity, computation complexity and time complexity there. So all of these things is about the sorting and order statistics. And then we will talk about the graphs and networks, how we can implement the graphs. For example, for shortest path finding problem, for traveling salesman problem, for search techniques, and we will talk about the MP completeness uh, in this part. And in the next part, we will talk about the algorithm design techniques, for example, divide and conquer, that you may heard about it. So greedy algorithms, which is very famous in both engineering and computer science. Dynamic programming, which is also a very nice algorithm. Backtracking algorithm. Branch and Brown, which is the developed version of divide and conquer. It's very simple ideas, but there are very rigorous algorithms there. So the difference is based on their computational complexity and the problem that you are solving. For example, for divide and conquer, if you are facing with a problem that is not large, is small, so it's good to use this in terms of the efficiency. But when you are going to solve a larger problem, so you have to use another version of the design techniques to meet the complexity limits that are in your design and in your problem. So in this number 6, advanced algorithms, we will talk about distributed algorithms, parallel algorithms, advanced algorithm analysis, and so on.